All right, I've got the thumbs up. So I'd like to welcome you all here. I'm Chris Silva. If we could get the slides up, Jeff. Should also congratulate you all for making it through the week and for being the roughly 50% of the folks who actually realized that this started at 7:45 instead of 8 o'clock today. Yeah, there you go. Yeah, I may be interpreting that poorly. So here we are. We're back at the Transformative Vertical Flight Workshop number 5. Once again, Chris Silva, the local chapter president. I will talk to you in 2 voices today. Right now, I'm talking to you as the president of the AHS San Francisco Bay Area chapter. Like to welcome all the visitors and any local folks. Like to welcome you to join AHS. We do some technical activities. We try to do monthly technical seminars. We do some social events and charity. It's a fair amount of fun. It's also a lot of work. There's a lot of volunteers who have helped out here. I'd like to thank them because this has only run as smoothly as it has because of their hard work. They come here before we start and they leave after we do. Some logistics. Downstairs is where lunch will be. Today, I believe, is fajitas. And and so it'll be in the dining area downstairs. Where we are upstairs, we've combined multiple rooms into this workshop room. This is the only room that we have today. If you guys want to have side meetings, there's the mezzanine outside, and there's also potentially downstairs in the lounge area down there, or sometimes they'll let you sneak into the cafeteria area. But the Sonoma room, which is across the way and had been available to us, is not available today, unfortunately. If there's an emergency, there's actually exits behind each of these projector screens, and then the entrance that you came in there. If it gets really bad, there's also another exit back here. Find ways out is the important thing to know there. That was yesterday's schedule. Talk about today's schedule. So first up, I'll be talking a little bit about what NASA is doing, eVTOL and not eVTOL. It's going to be, I'll explain that there's a lot of things that NASA does, and there's a smaller subset of things that I've been more directly involved in. Afterwards, Rob McDonald will come up here. Sorry, Rob, I didn't see that I have your name spelled wrong there. And then after that, we'll have a panel moderated by PK, and then we'll have another speaker, John Badalamenti. I hope I got that right. And then we'll have a networking break sponsored by Ricardo out there. So we'll have coffee and water for you guys to drink, and then we'll come back in here and have some more presentations. Mike Hirschberg will come up here and introduce some of those folks, and then we'll break for lunch. Like I said, lunch will be downstairs. It's a fairly short lunch, so we're gonna have to be fairly quick. And if everybody who registered shows up, then it's gonna be pretty crowded too. So please bear with us. We've been bursting at the seams all week, and that isn't changing. And then we've got a pretty full afternoon schedule too. So panels in the afternoon, and then I'll give some closing remarks and try and summarize from my perspective and other folks that I have gotten a chance to talk to what I think we've learned here and maybe what's coming up. So now on to NASA. So I am working at NASA Ames Research Center. I work underneath the Revolutionary Vertical Lift Technology program, or project. I'm a sub-project technical lead for optimization process and conceptual design. And NASA does many things. There's that first A in NASA, and in aeronautics, we care about things that include high altitude, long endurance UAS, the top of the screen here, and you can kind of see that any place where things are flying, NASA has has a contribution or has contributed in the past and looks to contribute in the future. For transformative vertical flight here, you can see that there's still the rotary wing kind of sitting off there on the far right. We also are looking into these emerging markets. So down at the bottom of the screen, you see unmanned aircraft moving around, potentially doing commercial missions, and then also there's this idea of moving people around in urban areas, and urban air mobility's the phrase that's been used for that. And there's lots of overlap and lots of things that are specific. One of the key themes that I want to get across is that there are many things that NASA's doing, and it's not always clear how these things interact and integrate. And unfortunately, I don't have enough time or actually the proper depth of knowledge to really bring all the pieces together, but I'll try to bring some of them together. So urban air mobility and moving around. Here we've got kind of some of the concept vehicles that we put together, flying people around San Francisco. That's just one thing. You can kind of look at emerging markets. We've identified 4 different emerging market opportunities, in which with each of these opportunities also come challenges. Challenges are good because then researchers have something to do, something to contribute. Small, medium UAS on the left-hand side, urban air mobility, thin, short haul, more of a conventional takeoff and landing thing, and large unmanned aircraft and high-altitude aircraft. So there are certain themes. There's a theme that some things have to do with flight physics, some have to do with decision-making, some have to do with flight rules and interaction. And so what I've been involved with are kind of the flight physics portions of it. So electrified aircraft, we've talked a little bit about that. We're going to talk more about that. So figuring out what really flight critical and flight weight components for electric propulsion really are, and not necessarily solving the problem for any particular person, but trying to solve as many problems that we can for everybody. Vehicle noise, that's been talked about, and that's something that cuts across several of these, maybe not the large UAS and HAIL. Operating in adverse weather and having vehicles that are robust, that can not only tolerate that, but can operate without much degradation. And that includes not just what you would think of in terms of icing, which has historically been something that we've looked at, but sometimes rain and wind can be a problem. Decision making, so there's a lot of people at NASA working on autonomy. NASA, not only on the aeronautics side but on the space side, has done a lot of work here, and we continue to do the work trying to help industry. And as PK we have here is a great example of the integrated air traffic management. You look at all these aircraft, and that's certainly something that you need to think about, is how you're going to get all of these to work with an air traffic management system that is about right sized now, and what does it look like in the future. So the project that I work on, RVLT, historically, before FY17, we've been looking at kind of larger aircraft. So here's a spectrum going from very small aircraft on the left-hand side to very large aircraft, and things that are vertical, things that don't need a runway to operate. Historically, we've looked at things that are kind of man-carrying and not really small man-carrying, so maybe not a single passenger aircraft, but larger, up to things that are quite large. And I've scattered some graphics down there to indicate some of the concept vehicles that we've looked at. So earlier in the week, I presented the 3 green vehicles that you see there, talking about how do we make conventional rotorcraft more environmentally friendly. Wayne presented those 3 blue aircraft there for this idea of operating man-carrying aircraft in urban areas and what technologies are involved with that. And then on the the far left-hand side, you saw Patricia had shown work that was done on small UAS, and our focus going forward, our guidance right now is to really focus on technologies that are kind of on the larger side of small UAS up to things that are carrying dozens of people. And for the folks who weren't at the conference or didn't get a chance to see Wayne Johnson's talk, he presented this slide here, which is an explanation of why we do concept vehicles. So NASA's not going to design any particular aircraft. As a matter of fact, we went out of our way to find aircraft that were sensible but didn't look like anybody else's aircraft, because we didn't want to indicate that we had found the winner, because we haven't found that winner. And we also wanted to see if there were some recurring themes, things that are vehicle agnostic or perhaps mission agnostic that are common, that we can try and improve on for everybody. And so you can see here, propulsion efficiency, performance. You guys can read much faster than I can say, but there's lots of things that we plan on doing. What we plan on doing is taking these aircraft and using them as ways of grading how well we've gotten and what work we still have to do to figure out where the high payoff areas are. And for each of these areas, there may well be NASA research that comes about. And so, you know, if you haven't already seen the NASA Technical Report Server, that's a great asset. You know, you might want to start looking at these words as being keywords to search and seeing what's going on. And with that, I think we will move on to the next speaker.